Welcome to STEM Professionals. In this video, we will discuss the problems and conceptual exercises of Chapter 2 from the book James S. Walker. So let's start with the video. So to solve this question, we have to first refer the problem number 74. So this is the figure for problem 74, and here a carpenter accidentally drops her hammer and the hammer passes to two windows of equal heights, as you can see in this figure. Now in this question we are given with this VT graph for the hammer dropped by the carpenter. Now here we notice that the time when the hammer passes the two windows are indicated by this shaded region, this one and this one. This is for window 2 and this is for window 1. Now what we have to tell? We have to tell that is this shaded region corresponding to window 1 is greater than, less than, or equals to the area shaded region corresponding to window 2. So this is what we have to tell in the A part, and in the B part we have to choose the best explanation among the following. Now one concept we know, that the area under VT graph, it gives the distance traveled by the particle. In this case the particle is hammer. Now we also know that the window have same height. Now so the hammer travels the same distance as it passes to each two windows. Therefore we conclude that the area of the shaded region corresponding to window 1 is equals to the area of the shaded region corresponding to window 2. So the answer would be that the region would be equal, the shaded region would be equal. Now the best reason will be the second option. The windows are equally tall, because we know that windows are equally tall, that is why this area is equal. Now other two statements are true, but they are not relevant to this question. So here we are given that several swimmers jump from a bridge into the river below, and it is estimated that the swimmers hit the water 1.5 seconds later. Now there are three parts that we need to solve in this question. In the A part we have to find how high was the bridge. So let me first show everything on the on this figure. So here you can see I've just picturized only one swimmer, but there are several swimmers over there. Now here they jump into the river, and let this is the initial position x0 equals to 0, and let this be the final position xf. Now the time taken to cover this much of distance delta t we are given to be 1.5 seconds. Now in the first part we have to find how high was the bridge. Basically we have to find this final position xf. So for that we can use this equation that we studied earlier. It is x is equals to x0 plus v0 t plus half at square. Because we know time, that is why we have used this equation. Now acceleration in this case would be acceleration due to gravity, and we have taken this direction to be our positive direction, and acceleration due to gravity is also in this direction. So in this case a would be positive g. So we can replace this a with positive g. Now we can put the values. Now initial position we have 0, this term would be 0. Initial velocity for the swimmer is also 0, so this term would also be 0. So 1 over 2. Now g is 9.81 meter per second squared, is a standard value, times t. Now time it took is 1.5 seconds and its whole square, and this x basically represents the final position. So xf would be equals to, we can solve this by using our calculator, and we'll get the answer to be 11 meter. Therefore the bridge is the river is 11 meter below the bridge. This would be the answer for the A part. Now next we have to tell how fast were the swimmers moving when they hit the water. So what we have to tell? We have to tell the velocity of the swimmers at this position when they just hit the water. So it's a pretty simple question. We can use this equation. V is equals to V naught plus AT. Initial velocity we have 0, so this would be 0. Now acceleration, same, g, it is 9.81 meter per second squared. Now the time at which we need to find the velocity is this 1.5 seconds. So 1.5 seconds and its whole square. So this would be equals to 15 meter per second. So this would be the velocity of the swimmers when they just hit the river. So this would be the answer for the B part. Now next, the final part is left, where we have to tell what would be the swimmer's drop time if the bridge was twice as high. Now what it is saying, that if this distance is doubled, then what would be the time taken by the swimmers to reach to the river. So same equation, this equation we can use. So x is equals to x naught, v naught is 0, directly we can write is equals to 1 over 2 gt square, and from here we can write that this is for the C part, that t would be equals to 2 times x divided by g and under root. Now initially we calculated x to be 11 meter, but they want that this distance is twice as high, so we can write this would become 2x, so is equals to under root 2 times 2x would be 11 times 2, that is 22 meter. So 22 meter divided by 9.81. So this would be equals to 2.1 second. One thing that you should know that generally people do mistake here is they think if this distance is doubled, then the time taken to reach to the river will also double. No, but that is not true here. Why? Because the position x is not a linear function of time. It is proportional to t square. So if displacement this x is doubled, t would not be doubled. So this would be the answer for the C part. So here in this question, we are given this basketball player that throws the ball straight down to the floor, and then the ball bounces straight up and return to the floor in just 3.2 seconds. Now let me first show this on the figure. So after striking the floor, the ball rises up, straight up, reaches to the maximum height, and then back to its original position like this. Now the time taken during this motion is just 3.2 seconds. Now what we need to calculate, we have to tell what was the ball's greatest height above the floor. So suppose here this is the floor, this is the floor here. So this height we have to calculate, this total height from this point to this point. Now this height, if you calculate this height or from this point to this point, it's same, it's one in the same thing. Either you calculate this height, either you calculate this height, it's one in the same thing because they are equal. Now one more thing we know, that the time taken by the ball to rise will be same the time it takes to fall, because it is a case of free fall. So the time taken by the ball to reach from this point to this point will be equals to the time taken by the ball from this point to this point. We're going to consider this motion, and here at this position x naught, we're going to take this is initial position, that is equals to 0, and the initial velocity at this point is also 0, and this direction will be taking positive, and this is the final position xf. Now since we have taken the downward direction to be positive, so in this case a will be equals to positive g. Now let us calculate this xf. So we can use this equation, x is equals to x naught plus v naught t plus 1 over 2 a t square. Now initial position is 0, this is 0, initial velocity is 0, so 0 plus 1 over 2, now a is g here, so g t square, this is equals to x. So we obtain that x is equals to 1 over 2 g t square. Now we have to calculate the position when time is half of this value, because the time taken by the ball from this point to this point would be half of this, that is 1.2 seconds, because the total time from this point and then back to this point is 3.2, so half the time would be 1.6 seconds only. Now we can put the value, so x is equals to 1 over 2, g is 9.81 meter per second squared, times t is 1.6 and it's squared. Now we can solve this by using our calculator, and we'll get the value of x to be nearly 12.6 meter, and this would approximately equals to 41 feet. So we have calculated that this distance from this point to this point is 12.6 meter. So this distance would also be 12.6 meter. So the maximum height reached by the ball is 12.6 meter.